Alright, today is the discussion of 4.4, which is the basic part of talking about integrals. And we're going to talk specifically about the fundamental theorem of calculus. And there's two parts. This particular part is part 1. So what this is the shortcut. And if you notice up here, I have the definition of an indefinite integral. I'm just going to make sure I have stuff to write with. And right here, here's my definite integral. I know because I have interval. I have a starting point A and a starting point B. Excuse me, starting values. And this is my definition of what I compute as net area. All right, and it's a limiting process of a summation of an infinite number of rectangles. And we're going to move away from that to our shortcut. So if you take a look at here, now I'm redefining that this is still net area, but the way I'm going to compute it is differently. If you look at f, f is a derivative of this capital F. And so this means this is the antiderivative. So all I really need to do is figure out the antiderivative, substitute b into that antiderivative, substitute a into that antiderivative, compute the numeric values, subtract them, and you get your net area. So here's my first example. Here's my derivative, x cubed. My antiderivative is x to the fourth over 4, or 1/4 x to the fourth. And if you take a look, I'm going to put in 1, and when I put 1 into x to the fourth over 4, I get 1/4. When I put a negative 1 in there, I also get 1/4, and I get a net area. Well, I compute that as 1/4 minus 1/4, and I get 0, so I have a net area of 0. And I'm just going to draw a little diagram of why this is. X cubed looks like this going to 1, and it looks like this going to a negative 1. And so these areas are the same amount. The only difference is this area is negative and this area is positive. So its net area is going to basically become 0 because their absolute values are equal, and you have just as much negative area as you have positive area. And so they end up getting a net area of 0. Alright, so I'm going to apply that to 3 examples right here. And again, all I do is I compute the antiderivative for each of these. And so I'm going to look first of all at what the antiderivative is for x squared. And what I do is I raise my exponent by 1. And what I do, rather than divide by 3, I multiply by its reciprocal. I just think it's less of a hassle. And then when I have fractional coefficients, it's easier to be able to compute what my coefficient is up front. Again, I look at this as x to the 0. So when I add 1 to this, I'm going to get x to the first. And I'm going to multiply by the reciprocal of 1, which is 1, so that's not going to change this coefficient. And I'm going to evaluate it from 1 to 2 here. Now, here's the important part. You're going to first substitute that 2. You're going to substitute that b. So the way that I write that is I use little brackets here. And I'm going to have 1/3 times, what am I cubing? I'm cubing 2 minus 3 times 2. Okay, so this is my b. Minus, over here, I'm going to do the same thing, and I'm going to have 1/3, and I am cubing the 1 minus 3 times 1. And I'm going to evaluate each of these and then subtract them at the end. So 2 cubed is 8. 8 times a third is 8/3. And I have 8/3 minus 6. Over here, minus, and then over here, 1 cubed is 1. 1/3 times 1 is 1/3, minus 3 times 1, which is 3. Okay, so 8/3. 6 is 18/3. Minus, I'm going to have 1/3 minus 9/3. That's what 3 is. And now over here I'm going to have a negative 10/3 minus negative 8/3. And I get a negative 2/3 is my answer. So there must be more area under that. Alright, now I'm going to show you how I can do this on my calculator to check to see if my answer is correct. And I should be able to do that here. I'm going to delete my screen so I don't have. And I'm going to do math, I believe. And I should have an integral. And I'm going to put, what was that equation again? It was x squared minus 3. And I'm going to evaluate it from this is going to be 2. This will be 1. I think that's why I was evaluating it from 1 to 2. Press execute. And I get negative 2/3. So it's a quick way to check to see if I did it correctly. Alright. So let me just put that on hold here for a second, and I'll do this next one. Now I'm going to rewrite this one down here. And this is number 2, gives me a little bit more room. I'm going to integrate from 1 to 4, and I'm going to write this in exponential form. So rather than having square root of x, I'm going to write x to the 1/2. dx equals, okay, so I figure out the antiderivative. So I'm going to add 1 to this exponent. So I'm going to get x to the 3/2. Over here is my 3 is my coefficient, and I'm going to multiply by its reciprocal, which is 2/3. And when I do that, I'm going to get 2x to the 3/2. Now I can mentally take the derivative of this, and I would take 3/2 times 2 and get 3, subtract 1, and I'd get the 1/2. And I'm going to evaluate it from 1 to 4. And when I do that, I'm going to have 2, 4 to the 3/2 power. That's my b. Minus over here, I'm going to have 2, 1 to the 3/2 power. That's my a. 4 to the 3/2 power, that means I'm going to take the square root of 4, which is 2, and then cube it and get 8 and multiply by 2, and I get 16. Minus 1 to the 3/2 power is 1, times 2 is 2. So I should get 14 as my answer. Alright, let's come over here, and let's see if I can get the same answer. Again, my equation was 3 times the square root of x, evaluated from 4 to 1, I believe. And I get 14, so I checked that I did my work properly. Alright, so now we're going to do this one over here. Here's number 3. I'm valuing from 0 to pi over 4 of secant squared x dx. The antiderivative of secant squared x is tangent x. And I'm evaluating that from 0 to pi over 4. So that means the tangent of pi over 4 minus the tangent of 0. The tangent of pi over 4 is 1. Tangent of 0 is 0. And I get 1 as my answer. Again, I will just check my work. So I'm going to integrate. And I'm going to have parentheses 1 divided by cosine of x parentheses squared. And remember that's secant, and over here I'm going to have, I gotta get to pi here, shift pi divided by 4, 0, execute, and I get 1 as my answer. Alright, so that is the basics of using the shortcut